I'm Alex Filipenko. I'm a professor of astronomy at the University of California, Berkeley.
Thank you.
Well, thank you, Randy, for that very warm introduction. And it's so great to be back in Hawaii on the Big Island. Yeah. I've been privileged to use the Keck telescopes for about 27 years at this point, starting with Keck 1 in 1992, I believe. And it's really a great privilege to use these fantastic telescopes on one of the world's greatest sites. You know, astronomy is great, the viewing is great from Mauna Kea. And we're really quite privileged to be up there because we know that the summit of Mauna Kea in particular has considerable cultural significance, and we want to share with the public here in Hawaii especially the findings of this kind of cutting-edge scientific research that can really only be done here and very few other places. And so it's one of the things I want to do. I want to tell people overall, and especially Hawaiians, about what kind of great science we're doing on Mauna Kea. Because this article was written in 2001 about our group's work back when we thought we knew how it would end. Here we are nearly 2 decades later, we've done more research, and now we're not so sure how it will end, but I'll tell you about that later on. My talk is about the accelerating expansion of the universe. The expansion is speeding up with time. Now that's really weird because we expected it to be slowing down. So it's an expanding universe. But there's something peculiar about the expansion. Let me pause. What's peculiar about this diagram as I've drawn it? Yeah, we're at the center. Why would that be? You know, do they not like us, these other galaxies? Is it something we said? Do we smell? No, we don't think that we're in any privileged position. We think that we would see all the others moving away with a speed proportional to distance, no matter which galaxy we happen to live in. And I like to give, as an example, a one-dimensional universe where I have the space stretching and the galaxies, the ping pong balls, don't, for reasons I'll describe in a minute. And as the space stretches, each of them thinks that the others are moving away, and they are moving away. The more space there was to begin with, well, the greater will be the speed of recession. So this all makes sense. And you know, the universe is either infinite or it wraps around. So I'm not trying to fool you in some weird way by having just a finite universe of this sort. You know, everything has mass, everything pulls on everything else because of gravity. When you toss an apple up, Earth's gravity slows it down and eventually brings it back. So we expected the universe's expansion to be slowing down as well, and perhaps even someday stopping and reversing course into a big crunch. Well, we actually measured that the speed of expansion is increasing. The universe's expansion is accelerating, and that's presumably caused by some sort of a repulsive dark energy. 2 teams had about the same result at about the same time. That made it more believable, and more physicists took it seriously, tried to prove us wrong. That's okay, that's the spirit of science. But we use this term anti-gravity hesitantly because people ask us, can we attach this stuff, whatever it is, to our cars and levitate over Bay Area or Kona traffic jams? And we think that you can't do this. It's either a property of space itself that you cannot harness. So the editors of Science magazine proclaimed this to be the single most important discovery that year in all the sciences. And the caricature of Einstein is surprised here, not because he's blowing multiple universes out of his pipe. You might not have known that there are multiple universes and they come from the pipes of famous theoretical physicists. Dark energy is the mysterious substance or energy that we think is causing the universe's expansion to speed up with time rather than to slow down. No one really knows what dark energy is. It's sort of a generic word or term we have for this stuff that's causing this really strange behavior for the universe. And now there's this dark energy. So my goodness, to the youngsters here, if anyone tells you that astrophysics is dead, there's nothing left to be discovered, you tell them, what about the origin and true nature of dark energy and dark matter? 95% of the universe is still mysterious. Dark energy really fascinates me because, first of all, it was completely unanticipated. We thought that the universe would be slowing down, not speeding up in its expansion. And we don't know what it is. You know, it could be some vacuum energy, or it could be something that permeates space but is not an intrinsic property of space. We need to understand what this stuff is because it constitutes 70% of the total matter plus energy content of the universe. So how will the universe end? Well, if the dark energy is the cosmological constant, and there's the same amount per unit volume, but the volume is growing, then the universe will be a runaway universe, accelerating, going ever faster with time. So if you want to look through a telescope at a galaxy with your very own eyes and not just look at a picture, you'd better go to your local telescopes. Yeah, maybe at Halepahaku there, they have all these telescopes set up. You'd better go and look sometime soon in the next few tens of billions of years, because beyond that time, all of the galaxies will have been whisked away to such great distances that we will no longer see them.